So we're going to go ahead and start exploring action potentials, this idea of how neurons send electrochemical signals. One of the things to start with is this idea of concentration gradients. A concentration gradient is a difference in concentration across a membrane, which we can see with the inside cell having more of a concentration of the substance than the outside cell. Now, we can create a concentration gradient through something known as a protein pump. This is something that does require energy, and essentially we are moving things against their concentration gradient to one side of the cell. So with this energy, we are essentially forcing things more on one side. One thing to consider is that if we are looking at molecules with a positive charge, such as atoms such as ions, we can build up more of a positive charge on one side than the other, and that is something we are going to take advantage of. It's something called a membrane potential. With that cogradient, we have the potential to do work. Now we can also release it. So we can change this by essentially letting things back across the membrane. We do that through protein channels, ion channels, and essentially we open a door and things naturally want to spread out. It's a process called diffusion. They will simply diffuse back to the other side of the cell so we can remove some of that positive charge. So messing around with charges is going to be something that we focus on a lot with action potentials. One of the ways that we have set up these differences in charges is through pumps. So let's look at resting. We have a difference on the inside versus the outside of that cell. One of the differences is that we are more negative on the inside. We can see that through the graph on the left. And we have a bunch of negative proteins in there. We've also built up a concentration gradient, where we have lots and lots of potassium on the inside and lots of sodium on the outside. So how did we do that? Here's my first joke. We set it up, as I mentioned, using a pump, and this pump is called the sodium-potassium pump. It's going to hang out in the membrane. We have the inside and the outside. And here's the joke, the sodium-potassium pump is lonely. And it asks sodium, hey, sodium, do you want to hang out? And sodium said, nah, and left. So it went up to potassium and it said, hey, potassium, do you want to hang out? And potassium said, okay, and came on in. So that is essentially the setup for how we created this concentration gradient. Now, in order to send a signal, we're going to need to make that inside more positive. And the best way to do that is to simply let positive ions inside. So our first step is we essentially let sodium, that is sitting on the outside, in through ion channels, through protein channels, so no energy is needed. This action potential will actually trigger the next action potential by opening up these same ion channels, which will trigger the next action potential, trigger the next one, and so forth. These are self-propagating action potentials all the way to the end. Since we do not want to continuously open the channels around us, we're going to have to temporarily reset so that our negative inside is now more negative once again. Easy way to do that is to simply open up another ion channel and let potassium out. So my mnemonic is, for the rise, sodium's like, wow, this party's really jumping, and it goes ahead and comes on in. And then for the fall, potassium is going, man, this party's getting really crowded, and it goes ahead and leaves. Now for our refractory period, we actually end up a little more negative. We are unable to send any signals because we've ended up in the reverse of how we were for our resting, which we can kind of see over there. We have more sodium. We have sodium pretty evenly spread out and potassium pretty evenly spread out. So how exactly are we going to reset? We do the same thing that we did with our sodium-potassium pump. We move that sodium in, we move the potassium out, and then we can go ahead and head back to resting, where we have, once again, a lot of sodium, a lot more potassium on the inside and a lot more sodium on the outside. The only other thing to mention in this picture is going to be threshold. When we are stimulating the next action potential, we can sometimes stimulate it so it doesn't quite reach threshold. We will fall down and not give any response. We will not pass on that action potential. However, the moment our signal reaches that threshold level, we are always going to rise up to action potential and fall, fully sending a signal. It is what's known as an all or nothing response. Hopefully that helps and gives you guys something to study.